Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of probability distribution for a continuous random variable. When we have a probability distribution for continuous random variable, the probability distribution is also known as probability density function. And it has the same notation, which is fx, and this is similar to what you have seen in the case of probability mass function. So recall, if you have a discrete random variable of x, therefore if you have fx, which is the probability distribution, the specific name for it is probability mass function. Okay, and what it means really, fx here is probability of x equals to a specific value. So this one is single specific value. Okay, right, this is what we have already seen in the case of x being a discrete random variable. Now is about probability density function, and this is also having the same notation, mathematical notation, which is fx, and this is reserved for the case of having a continuous random variable. So here we have x is a continuous random variable. Therefore, what is the statement is saying is that if you want to find the probability of our random variable here being between two values, between a and b, so the probability is described in terms of interval. Okay, so x here, our random variable, is between a and b. Now notice that the difference for discrete case is we are talking about a specific one single value. So probability of x being one single value, taken one single value, but for this one, x is between a and b. So in order to find the probability of random variable x being between two numbers here, what we can do is we can apply integration process. So here we will supply the probability density function. So we will integrate this function with respect to x, and here will be the limits associated with a and b. So a is the lower limit and b is the upper limit. Okay. So other common names are probability density or density function or density or PDF. So PDF is probability density function. Now, to be a probability density function, fx must satisfy the conditions where each value of it must be non-negative. This is a similar condition as given or as you have seen in the case of discrete random variable. And here, if you integrate for the second condition here, if you integrate the function from its lower limit to its upper limit, the result is going to be equal to 1. So in this case, when x is a continuous random variable, you are dealing with integration. But when x is discrete, when you're talking about discrete random variable, this condition here, the second condition here, is related to adding up the value of fx. So the process here is just summing up, and we use the notation of sigma. This is just some information based on what you have seen in the previous video. So I'm just going to compare the difference between condition 2 that is seen right here with what you have learned when x is a discrete random variable. Okay. All right. Now, if x is a continuous random variable, so here is our x, it is continuous, and a and b are real constants, we have real numbers. Therefore, the statement here holds true. So the statement here is true, where you can see that the result for finding the probability of x between a and b, to be more precise, x greater than or equal to a and x being less than or equal to b. Well, it is the same result if you find probability of x greater than or equal, less than b, greater than or equal from a and less than b. Or it is also the same when you find the result for x being greater than a but less than or equal to b. And the result here is also the same with finding probability of random variable being greater than a and being less than b. Now, what is the implication of the above statement here? Well, what we can say is that based on this above statement, we can see that somehow the sign here doesn't really matter. For example, you can have either greater than or equal to, or you can have greater than. Whether we have this part here, whether we include the equal sign to this inequality, to this symbol, doesn't really matter. So in other words, we are saying that equal sign is, you can think of it as having equal sign is actually not so important. Okay, equal sign is not so much important. Or in other words, you can think that probability of x, the random variable, being equal to a specific value, such as x, is going to be equal to 0. Okay, probability of random variable equal to a specific number, for example a or b, is going to be equal to 0. Why do you think the statement is such for continuous case? Now, in order to perhaps explain that, let me just try to compare two different cases. The first one is when we talk about discrete random variable. Okay, so let's say we have x is a discrete random variable, and it can take values such as, and it can take values such as, let's say 1, 2, 3, 4, 5 with equal probability. Okay, right, now try and imagine you have some sort of this scenario. You have like a real number line here, so we've got 1, sorry, this is 1, 2, 3, 4, 5. So x is going to be either this value or this one or this one, this one, and this one. Yeah. So if I ask you what is the probability x is equal to 3, in order to answer this question, we need to know how many possibilities we have altogether. So altogether we have 5 different possibilities. That means x can take either this value or this value or this and this and this. So total number of possible values is going to be 5. And if I want to know what's the probability x is equal to 3, I need to know how many times that can happen. And obviously the number of times this can happen is just 1. So probability x is equal to 3 is going to be 1/5. Now, if we try and do something that is quite similar to this, for example, let's consider the case of continuous random variable, okay, where we have x and it can take values in a range, okay, because it is continuous, so we have to express x in terms of a range or interval. So x can be between 1 and 5, Okay, can take any value between that, and this value can happen with also with equal probability. Okay, so if I sketch this real number line, so here we've got like 1 2 3 4 5. Okay, just for some simple visualization really. So basically x can take any value in this range, okay, from 1 to 5. Now if I ask you what's the probability of getting x equals to 3, a lot of students will answer that the probability is 1 over 5, which is wrong, by the way. So that probability here is wrong. The answer is wrong. Now if you want to find what is the probability x is equal to 3, what we need to find is we need to know, okay, we need to know how many possible answers or possible outcomes that we can have at the bottom here. How many? And the number of possible results is not going to be 5 because we have infinite possible values here. For example, it can be 1.5, it can be 1.536, it can be 1.49312. So this is are the values around 1.5 only, but I think you get the idea. What I'm trying to say is there are a lot of possible values that you can take along this real number line from 1 to 5. Therefore, this number here is actually uncountable, but you know that it's going to be a lot of possibilities. Okay, so because the number is going to be a lot, we can just imagine we are going to divide something with such a big number at the bottom here. Okay, and if I want to find what's the probability x is equal to 3, I need to know how many times I have this value. How many times can this happen? Now the value of 3 happens only once, so the number of times it can happen is just 1. And imagine to have the value of 1 divided with such a very large number. The answer here is going to be very much close to 0. So we can actually say that in terms of finding probability of a specific number such as this one, you're going to get the result here is equal to 0. Therefore, that is why when we talk about continuous random variable, we usually will be more interested in finding the probability of x being in between two values, being expressed in terms of interval. So it's different here for discrete random variable. Discrete random variable, we can express it in terms of one single specific value. Okay, and because of that, since the probability at a specific point here is 0 when it is equal to something, therefore the notation here, whether you have less, greater than or equal to, doesn't matter, you know, because at probability x equals to a, it's going to be 0. Therefore, it's going to be equal to this part. So this part here is going to be equal to this part. And similarly, for example, x probability of if you have x being less than or equal to b, the sign equal here doesn't matter because the probability of that equal to b is going to be 0, and therefore we can express it in terms of x less than b, so you will get the same result. And why we get the same result is because of in continuous random variable, when you talk about continuous random variable, the probability of x taking a specific value is going to be close to 0, equal to 0. Okay, so if I ask you what's the probability x is equal to, for example, 4.31, so the answer is still going to be 0 because based on what I have explained to you just now, 4.31 can only appear one time, and 1 divided with such infinite number of possible values here, which is going to be a large number of possible outcome, then 1 divided with a big number is going to be very close to 0. Okay, right. Okay, now let's try and look at this example. So example 3.6. So here we've got a probability density defined as such. So this is our fx. And the question is asking you to find k, and then later on you have to find what's the probability of our random variable between 0.5 and 1. So when we want to start this answering this question here, note that when you say this function is such for x greater than 0, it also means that the lower limit is 0. We can also express this part as x greater than 0 and less than infinity. So that is another way of saying this. Okay. In order to find k, we are going to start off using the condition that we have learned, which is if you integrate fx, the probability density, from the lower limit to the upper limit, the result should be equal to 1. So this is the condition for fx to be a probability density. Where do we get that? Well, we have seen it in this part. Okay, we have, hang on. Oh, what's going on? Hang on, yeah. Okay, there is something wrong with my slide right now. No, what am I supposed to do? Okay, let me just try this, discard. Okay, let's try this again. Okay, right. Now, in order to answer this question, what we need to do is we need to use the idea of this one, this fact here, that when you integrate the probability density function with respect to x, the result is going to be equal to 1. So here is the lower limit and this one is the upper limit. Okay. So that's what we're going to use. So I'm going to integrate this function. We have k, e, and here we've got like negative 3x dx. And the lower limit is 0. As I said earlier, this can actually be expressed as x greater than 0, less than infinity. So the lower limit that we should put here is 0 and up there is infinity. Yeah. Okay, so that's our starting point. Next, the result here should be equal to 1. Okay. Now k is a constant. We can take it out. So here we've got k. So we're going to integrate that with e negative 3x dx. This is 1. And what we can do next is assume u is equal to negative 3x. Okay, we're going to assume this as u. Therefore, du dx, okay, is going to be equal to negative 3. And therefore, dx is going to be du over negative 3. So, maybe I can call this 1. Okay, 1. And we're going to substitute this result into 1. So we're going to substitute this into 1. Okay. Therefore, what we have here is k, and limit is not going to be defined between 0 and infinity anymore, because now we are representing negative 3x with u. So dx is going to be replaced with this one, which is du over negative 3. And this must be equal to 1. Yeah. So negative 3 is a constant. We can consider taking it out. So we have k over negative 3. Integrate this function with respect to u must be equal to 1. And this is the result that we should know, based on what you have learned from calculus. If you integrate this function, the result is going to be the same one. So if I integrate e and we have u, so I'm going to get the same result, and that's what I'm going to do next. So here I've got here k negative 3, integrate this, we're going to get the same thing, and I'm going to substitute u with the original statement given here. So the result is going to be e negative 3x, and the limit is going to go back right to these values given here. So infinity 0 must be equal to 1. Okay. Then I can have negative k over 3. I'm going to express this in terms of positive exponent. So it will be 1e 3x. So we get rid of the negative sign, infinity and 0. Okay, hang on, let me just, perhaps we can consider. So this is what we are going to consider. This must be equal to 1, and I'm going to call this, I don't know, 2, and then I'm just going to focus on the left hand side of this one. So maybe it looks easier like that. So I'm just going to consider the left hand side of 2. Okay, so this is what I'm going to do next. I'm just trying to simplify the process and the look of it really. So what we have to do is we're going to substitute all the values here into this, and we have negative k over 3, 1 over, so 3 with infinity here, we can assume this is going to be infinity, and then minus 1 over e 0, 3 times 0. Okay, and here we've got negative k over 3, 1 over such a big number is going to be 0, minus e to the power of 0 is 1, so minus 1. So the final result is going to be k over 3. Okay, so from 2 we know that, k over 3 must be equal to 1, therefore k must be equal to 3. Okay, so that's the first result here, related to finding the value of k. Okay, next we are going to find what's the probability of our random variable between 0.5 and 1. Okay, so this is the answer to that, and we're just going to try and do it step by step. Okay, all right. So here we've got probability of x between 0.5 and 1, and in order to find this probability, we know that what we have to do is we have to, in order to find x between a and b, what we need to do is we have to integrate the probability density function with respect to a and with respect to lower limit a and upper limit b. Okay, so that's what we're going to do. Yeah. Right. Therefore, we are going to integrate this function here, and we know that k has already known, the value is 3, so we've got 3 e negative, this is 3x dx, and the limit is going to be between 0.5 and 1. So here we've got 0.5 and 1. Okay, so 3 is a constant, it can be taken out, so this is equal to 3 0.5 e and this one. And again, we can use the same idea or the same process. I'm going to call this 1. So we are going to let u equals to negative 3x. So du dx is negative 3. Therefore, dx is negative. Therefore, dx is du over negative 3. Hang on. Dx is du over negative 3. And we're going to use this, and we're going to use this and substitute this result here. Substitute this result here into 1. So substitute this into 1, okay? So what we have is we have 3, 1, 0.5. E negative 3x dx is going to be represented as 3. I'm not going to write down the limits anymore because this one is limits related to x, but what we have is we're going to replace this one with u, so e u, and then dx is going to be replaced with du over negative 3. Okay, then you can see that this part can be cancelled out. So we've got negative 1, negative can be taken outside, so eu du, and we're just going to use the result. We know that if we integrate this function here, we'll get the same result. So what we have is, I'm going to just write down this, and I'm going to substitute back the real value of u, which is negative 3x. So here what I have is e negative 3x, and the limit here is between, now we can use back this limit because these limits are related to x, okay? So the limits are 0.5 and 1. And this can be expressed as negative 1 over e 3x, okay? I'm just going to express this in terms of a positive exponent, 1, 0.5, and this is negative 1 e 3 times x, x is 1 is 3, so we're going to minus that with e 3 times 0.5 is 1.5. So this is what you will get, and punch in your calculator, you should be able to get that the answer is going to be 0.17334 if you want, or if you want to express it in terms of 3 decimal places, that would be just 0.173. Okay, I think that's all for now. Thank you very much for watching.